And I'm going to try to keep these up for every problem that we do. I'm going to keep it up because we're going to go ahead. Keep your factor sheet, keep your square root sheet out in front of you as we're doing these notes, because I'm going to continually ask you what, yes?
The second one is under supposed to be under twice.
Huh?
You put under.
Under the, oh, under the, I'm sorry, no fractions under, yeah, I don't need to say under twice.
Under the under.
No fractions,
That's right.
under the radical. Thank you.
Yeah.
Yes, we don't want under twice there.
Oh.
Thank you. Okay, so we want no perfect square factors other than 1 or the radical. Okay, all right. So you should have those 3 written down or close to here, and then we'll start, okay? Ready, guys? Okay. All right, so let me go over this again, and then we'll go into an example, okay? So again, I'm going to say right now, when we ask you to simplify a radical, it means that you have to go through these 3 rules, or these 3 things, and kind of check them off, and make sure that all of them are taken care of. If they are all taken care of, then you have the radical in simplest form, okay, or simplified. The biggest thing, guys, we're going to see today is this part right here, okay? No perfect square factors can be under the radical, okay, which means there can be no number under the radical that's a perfect square, okay? That means it still can be not factor, but it can still be simplified further from there. You cannot have any fractions under the radical, okay? We're going to see how we do this, how we break that fraction into 2 separate radicals. The numerator and denominator will both be separate radicals themselves, and then we'll simplify further. The last one is you cannot have any radicals in the denominator of a fraction, which means you can't have 1 over the square root of 4. That's impossible. So we're going to show you how to what we call rationalize. It's called rationalizing the denominator is what we call it. That's the process we use to eliminate the radical from the denominator. That's what we call it, rationalizing the denominator. Okay? Those 3 things today I'm going to show you how to do. Okay? And we're going to learn how to do that today. We're going to stop after we get done with that today, and then tomorrow we'll do the second half of the notes, which is on adding and subtracting radicals and multiplying radicals. So we're separating this section, like I told you yesterday, into 2 separate units, or 2 separate sections, so that's not so overwhelming to you. Okay? All right, so now we're going to go ahead and start with an example. That's why I want you to make sure you have your factor sheet out in front of you, / your perfect square factor sheet. Okay, your perfect square sheet. All right, here we go. Example 1. Until you get in the habit of knowing those offhand. You should try to be memorizing those. All right. Well, first of all, I'm sorry. I didn't mean to say example 1. Let's go down here. I want you to give you the first property that we're going to deal with today. We're going to deal with 2 properties. The product property of radicals and the quotient property of radicals. So let's do, first of all, tell you how we do the product. The product property of radicals. And then I'll add the quotient property of radicals here in a minute, okay? This says, product means what? Product means multiplication, doesn't it? Okay? The product property of radicals says that if you have the square root of AB, guys, what does the square root of AB mean? Does it mean A what? Times B, right? So you're multiplying 2 numbers together to get the product AB. Now, we're going to take this product, this AB, and we're going to break it up into separate radicals. So to simplify the square root of A times B, or the square root of AB, we're going to break it up into the square root of A times the square root of B. And that's what I'm going to show you to do today. Okay? Now this can be done in reverse order. Sometimes we'll be giving you 2 separate radicals and ask you to multiply them together to the square root of AB. So this can be used in both fashions, either starting here and getting this, or starting here and getting this. And I'll show you what that means here in a minute. But this is what everything we do now for the next 15 or 10 minutes or so is going to come off this property. Okay? The product property of radicals. Here's our first one to do. We're going to ask you to simplify, and we're not going to start off too hard here at the beginning here. we're going to simplify the square root of 24. So guys, this square root of 24 is really represented by the square root of AB. So ask yourself, first of all, ask yourself this always. Is 24, look at your perfect square side. Okay, not the factor side, the perfect square side. This is this side right here. Everybody have this out in front of you, okay? I want you to ask yourself, is 24 a perfect square? No, because when you take the square root of 24, do you get a whole number? No. So therefore, we know we can't simplify this yet. But we know we can simplify it. Because we know it's not a perfect square, but we can still look to simplify it. Now ask yourself, now flip it back over to the other side. Find 24 on your factor sheet. Find 24. And find factors of 24. Now turn it over to the factor side and find 24. Okay, ask yourself, are there any factors of 24 that are perfect squares? Any factors of 24 that are perfect squares? 4 and what? What would 4 times what is 24? 6, right? So 4 is a perfect square though, isn't it? So what we do now, watch, is I'm going to use my marker here and I'm going to show you, we're going to break this up into, looking at this property, I'm breaking up the 24 into separate factors. One of them being a perfect square. Which one was a perfect square, 4 or 6?
4.
Watch what I do. I put that one first, the square root of 4 times the square root of 6. I'm using this property here. I'm taking the product 24 and breaking it up into 2 separate radicals, where one of them is a perfect square. Now how do I simplify this? Which one is the perfect square again? 4. So what is the square root of 4? Watch. So that means that I cross this out and the square root of 4 becomes 2. This cannot be simplified, can it? 6 does not have any perfect square factors, does it? So bring down the square root of 6, and I've just rewritten the square root of 24 as 2 times the square root of 6. I've just simplified that radical. Okay? If you're confused, please do not worry. We're going to do enough of these that it's going to make sense, okay? I don't want you, that's why we're breaking this up into 2 separate days. I don't want you guys to feel overwhelmed on the first day. All right, let's do another one just like this, okay? How about the square root of 48? Can you see this, Mrs. T, okay? Yep. Okay, we need to simplify the square root of 48. Ask yourself, first of all, now turn your sheet back over to the perfect square side. Ask yourself, hopefully you're getting used to what I'm asking you now. Ask yourself, is, and what I'm saying is, I'll just show you what I mean. I want you to look at the perfect square factor and ask yourself, is 48 a perfect square? No. So now I want you to flip it over to the other side. Find 48 on the factor side. Ask yourself, are there any perfect square factors of 48 now? We're trying to break this up where we get a perfect square as a factor. Can you guys give me a perfect square factor of 48? Now a little hint to you. I want you to always find the highest. Find the highest perfect square factor of that number. Don't give me the lowest, give me the highest. Of 48. 16. Everybody find 16 on this factor? Good. So that means I'm going to break this up, guys, into 2 factors. One being a perfect square. Which one was the perfect square, Jordan? 16. So everybody put the square root of 16 here, times, what is the other number multiplied by 16 that gets me 48? 3. Okay, you see how I did that? All I did was break up the square root of 48 into the square root of 16 times the square root of 3, just like here. This is what I did, guys. 48 was my AB, my product AB. I broke that up into the square root of 16 times the square root of 3. Is what these broke up to. Now, which one of these can be simplified?
16.
The square root of 16, which is the perfect square. What is the square root of 16? 4. And once I take the square root, guys, there's no radical there anymore, so you can't take the square root of 4 again. Okay? Times what? Just square root of. Why can't I simplify the square root of 3? Because it is not a perfect square, and I don't have any perfect square factors other than 1. So therefore, it's simplified. Okay? Make a little more sense since I did the second one?
Yep.
All right, let's do a third one and see if we can. This will be the last one like this, and then we'll do a one where we start throwing in some variables. All right, I want to make sure I get enough examples so you guys understand. How about the square root of 98? What's the first thing I want you to do? Ask yourself, is 98 a what? a perfect square. Is 98 a perfect square? So what side should you be looking at? You should be looking at the perfect square side. I don't see 98. I see 81, I see 100. So I know it's somewhere between 81 and 100, but it's not a perfect square. So I know that's not a perfect square. Now ask yourself, go back to the other side, look at your factors of what number? 98. So find 98 on your sheet. Find 98 on your sheet, and you've got 1, 2, 7, 14, 49, and 98. Are one of those a perfect square? 49, right, 49. So let's put that down, guys. So now we're going to go the square root of 49 times the square root of what? 49 times what is 98? 2, right, good. All right, what is the square root of 49? So if you don't know that, go back to the other side. You should know that though. And what the square root of 49 is? 7. What do we bring down? The square root of 2. And we have our answer in simplified form. Bailey.
Would there ever be a case where they don't have to take these?
Are there ever going to be a case with the both perfect squares?
Yeah.
There will be when I get into the variables,
Okay.
yes. But it's when you're using variables and numbers. So that's a good question. Okay, are we good with those 3 examples? Can we move on to where we're now going to throw in some variable parts to it? Let's see how we do with that. Same concept, nothing different with the concept at all.